Function overloading in C++ is really no different than function overloading in most any other language where you're using it. However, if you're not familiar with this idea, it can be somewhat confusing. So let's step through it right here, and then I'm going to show you some code to see how it's actually working. Now, when we talk about function overloading, what we're really saying is we're going to have multiple functions in our program with the same name. However, each function that has the same name will have at least slightly different parameters. And the name of a function along with the collection of the parameters that it has or that it requires is referred to as its signature. Now, any function with a unique signature is in fact a unique function, even though the function name might be the same. Now, the return type does not affect overloading, and I'll explain that in just a couple of minutes. But now, to really understand this, let's jump out to some code demo and see exactly what's going on, okay? So if you'll notice here, in Visual C++ 2010 Express, I've got a example project out here that I'm including on the work files folder, and notice it's called the overload example, and I'm working in the OVR load C++ module. Now, I want you to notice what's happened here. Let's start down here first. I defined a function called calc this or calculate this, and it has one parameter, right? Now, let me undo. I just drug that by accident. It has one parameter. It's looking for an integer to be passed in, and we're calling it a, all right, for the purposes of this function. Then I have another function, and notice it has exactly the same function name, but this one has a signature. It's expecting 2 integers, and this one is only expecting 1. Then I have another calc this function, and this one, you'll notice here, is expecting, I keep dragging these things, I'm sorry. Notice this one is expecting 3 parameters, okay? Or you got to use 3 arguments to call this. Now notice each one of these is doing something different. If I just send one argument, it's going to take that argument and multiply it by 2 and return it back. If I send 2, it's going to take the first argument that comes in, multiply it times 2, then it's going to add the second one to that and return it. The third one is going to multiply the first one by 2, it's going to add the second one, and then the product of all that is going to subtract the third one from it. Now, notice how we call these, all right? Notice I'm just going to do a standard console out, and then I'll leave us a little message here with one parameter. Notice I'm calling calc this, and I'm passing one integer in. I'm passing 5 in. On the second one, I'm calling calc this, and I'm passing 5, 6. Then on the third one, I'm calling calc this, and I'm passing 5, 6, 2. And we're going to be able to see by what gets returned from these which ones are actually being run. Now, what really shows this, if you look up here in the function prototypes, and I talked about prototypes in a separate video if you haven't watched that yet, and it was cleverly entitled Function Prototypes. Okay, so if you'll go watch that movie, then you'll be able to see what we're talking about with prototypes. But notice this is very clearly showing you the difference between these various functions. All right, and this is called overloading, because based on the parameters that I send to this same function name, I'm actually going to run different functions. All right, so let's run this and take a look at it and see what we actually get. All right, now this one's a little different. I'm running this one off the desktop. Okay, and so let me make sure that I get the right one. And this was called overload example. And when we run it, you'll notice one parameter gets 10. And let's go back and check our code here. One parameter gets 10, and that's 5 times 2. The next one is 16. That's 5 times 2. Notice right here, plus 6. And the third one returned 14. So that was 5 times 6 minus 2. So anyway, right here, okay? It's 5, wait a minute, it's 5 times 2, that's 10, plus 6 is 16, minus 2, and that is 14, all right? So again, play with overloading. This is a very, very popular technique. It's used quite a bit in all programming. You can do some really neat stuff with this, but I want you to understand what function overloading is. This is a very simple example. When you get this, you got it, and this will open up all kind of possibilities for you with your coding. Welcome to Pointers as Arguments Part 1. Now, this is going to be a two-part video because in the first part I want to do a little chalk talk and a little animation through some code, and I want you to understand and get your head wrapped around using pointers as your arguments and kind of help you understand the mechanics of what's going on behind the scenes, and it will also really display for you why you would want to do this. And then in Part 2 we'll open up Visual C++ and we'll actually write some code and play with it and compile it and run it and let you see what's actually going on in code. So the first thing, let's look at some code we've got. Now, we've got our main function here that's returning an integer type. I don't have the return statement because I wanted the room here on the screen. But notice in this, we're creating an integer called number, and then we're going to create a pointer for that variable there. And then we're going to pass the pointer down to our function that we built, okay? And so these are our parameters, and we're going to pass some arguments down, all right? So notice we're telling it on our function definition down here that when we call calc, they're going to be sending you a pointer, okay? And then we're going to do some work with it, all right? So let's take a look at what's going on here. Notice that right up here at the top, when I create this variable called NBR, or number I'm calling it, but I'm creating a variable called NBR. It's a data type integer, and 3 is its initial value, all right? Well, notice at the instant that this thing comes into being, its address is 0029F850, and its value is 3, all right? No big surprise there. But then I create this pointer, and notice PNBR is a pointer. It's a pointer of integer type to this, to at number, all right? And so pointer now points to number, all right? And so the address of P number is, guess what, 0029F80. So this is pointing to this, all right? Pretty straightforward there, and the underlying value is 3. Now, I pass the pointer P number, which is pointing to number, to my function down here, okay? And so P number basically becomes A. Now, what I've passed is the address 0029F80 and the value 3 down here to A, and this itself says, okay, I'll take a pointer, no problem, I'm looking for pointers here. And it's going to make a copy of that and pass it in. Well, what is it copying? It's copying the address and the value, all right? Now, inside my function down here, calc accepts that pointer as an argument, and like I just mentioned, this address is copied to A, and then notice here we're dereferencing. We're saying, okay, whatever value is at A, well, guess where that value is? It is at this address, and we already know it's a 3, and we're going to add 25 to whatever's there. So plus equal means whatever's there plus 25 and give me the total. So it's 3 plus 25. So the value at this copied address, 0029F80, is manipulated, and then we return, right, the value, the dereferenced value of that, back up here to calc. All right? So what gets returned here to calc is that value. All right? Now, don't pay any attention to problems with the code. I greatly simplified this code down. Okay? I didn't put a reference in here for my return. Don't let that mess with you. What I'm really want you to see here is how this pointer being passed as an argument is being used. We'll clean up code issues and we'll make it a lot more realistic when we jump into the code in part 2. But for now, I want you to see the logic on how these variables, arguments, and parameters work when they're worked with as pointers. All right, so join me in part 2 and we'll build some code and actually take a look at this in action. Welcome to Pointers as Arguments Part 2. Now, if you watched Part 1, I kind of did a chalk talk and a little animation about how we can use arguments that are pointers, or we're passing pointers as arguments. And what we're really doing in the end, once it's all said and done, is we're more or less passing by reference. Not really, because we're not making an alias. We are copying, but we're pointing to the same place, and we can change the original variable value. So what I'm going to do here is, instead of typing a lot of this code, I'm going to copy it and paste it and talk to you about it so that I can spend more time explaining and less time typing and making mistakes. Okay, so the first thing I'm going to do here is notice that I'm going to create a function called calc, C-A-L-C, and we're going to have it accept a pointer as the argument. Now, I've created a function prototype up here, okay, so that we can use it without having any kind of compiler issues. And so I'll get to that in just a few minutes. All right. The first thing I want to do is jump into the main function here, and the first thing I'll do is create a variable that we're going to use, and the code for that looks something like this. All right. Notice we're creating an integer, and it's a variable named number, NBR, and we're setting it equal to 5 right off the get-go here. And then what we're going to do is we are actually going to come down here, and now we're going to create a pointer to number. So that's the variable we created. Well, now notice we're going to create a pointer of type integer, p number, PNBR, okay, to the address of number. All right, the little ampersand, remember, it returns you the address. And so we're saying, okay, point this to this. All right, and so once we've got that done, then what I want to do is let's print something out in our program so that we can see kind of what we've done here. And so I'm just going to do a standard console out, and I'll say the address of the pointer, and then notice I'm going to put p number, because that is the pointer that we created that's pointing to our variable. All right, and then what we're going to do is we are going to create an integer here, and with that integer we are then going to load it with the result of a call out to a function. So notice integer result, and we're going to set it equal to whatever comes back, and I shouldn't have done that, but whatever comes back when we call the calc function and we pass it this pointer, this p number pointer. Okay, I keep clicking my mouse and dragging, trying to show you what I'm doing. Okay, I'll stop that, I promise. So what we need to do now is actually go out and build this calc function. And so what I am going to do is simply go grab some code, and you will notice that if I get down here outside my main function, and I'm going to say integer is my return type, calc's the name of the function, and we are accepting a pointer as the argument, right? And so then if I put the body of it there, then what I'm going to do is put something that looks like this. Now notice, let me pull this back over here so that it looks a little more standard. Notice we're using our standard namespace from our console out, and I'm going to tell you when we run this, first thing we're going to do is send something out to the console saying the address that was passed to this function is number. So when we ran this and we pass this into here, first thing we're going to do is read what this is, and this line is going to write that out on the console for us and show us what got passed in. All right, and the value that was passed into the function, notice we're going to dereference NBR right here and see the value, and then we are going to add 20 to the value at this copied location. All right, because keep in mind, when this got sent in, it made a copy, but what did it make a copy of? All right, well, let me just give you a little note here, and make sure that you pay close attention to this, and I'm going to put this in a comment form right on top of this. When the pointer to number is used in this function right here, a copy is made, but the copy that it's making is of the address that's pointing to the same location. All right, because notice what I passed in was a pointer. When it gets here, it makes a copy of it called NBR, but actually what it's copying is the address that it's pointing to, which is the original NBR up here. Hope that made sense. If it didn't, go back and watch it real slow a couple of hundred times. And so then what we've got to do is jump back up here into our main function, and then let's just finish writing out our code. All right, and I'll paste some things in here. Notice the first thing that we're going to do, let me move this up so that it's a little easier for you to understand, and do a little housekeeping here. But what I'm going to do is I'm going to reach down here, run the calc function, passing in that pointer, and then it's going to return the result back to me and drop it into result. And notice what it's going to return is this dereferenced number after we've added 20 to it. Okay, and so right here I'm going to say that the calc passing the reference to number, the pointer to number rather, is going to return us a result, and I'm going to print it out right there. This is where we actually loaded it with our call out to our function. And then I'm going to print one more thing out to the console and show us what the number value is. All right, so let's run this, and you'll have to go through, I hope copying this code in doesn't confuse you, but it's a whole lot quicker and a whole lot more efficient than doing it with me typing it. We would be here probably the rest of the month trying to get through this. So I'm going to go into projects, and then I will go into pointer arguments, and then I will reach into debug, right click holding the shift key down, open this, and then I'll just type pointer arguments. And notice the address of the pointer, when I first started up here, the address of the pointer is 0031F884. Then when I come down here, the address, let me make this scroll up and bring this back up, and scroll that back down. The address passed into this function, which is right here. Notice 0031F884. It passed into here. It made a copy, but I've still got the same address here. The value that was passed in, I can see that right here, was 5. And again, that's what it was up here. And so now, if I look, calc p number equals 25. So it took the dereference value here to 25, and then when I jumped back up in here, I see that the value of this again is 25. Now it's a little confusing watching all the stuff scroll back and forth, and I'll go very, very slowly through this. Take a look at it, write the code out yourself, but understand what's going on here. When we pass pointers, we can still get back to the original variable because we're making copies of its address.